Hi everyone, and welcome back to our channel. Today, we'll be tackling the top 10 NLP interview questions, complete with clear, enhanced answers and practical examples to help you ace your next interview. So, let's dive right in. Question 1. What technique helps convert keywords into their base form in NLP? Answer. The best technique is lemmatization. It reduces words to their base form, known as a lemma. For example, words like playing, played, and plays all become play. Question 2. How can you compute the distance between two word vectors in NLP? Answer. Two effective methods are cosine similarity and Euclidean distance. Cosine similarity measures how similar two words are based on their vector angles. For instance, the cosine similarity between football and cricket is high, indicating relatedness, whereas between football and New Delhi, it's lower, signifying unrelatedness. Question 3. What typical features of a text corpus used in NLP? Answer. Common features include word counts, vector representations of words, part of speech tags like noun or verb, and dependency grammar structures. Essentially, all these elements help algorithms better understand and process textual data. Question 4. You've created a document term matrix with 20,000 documents. How can you reduce the dimensions? Answer. Techniques like keyword normalization, latent semantic indexing, or LSI, and latent Dirichlet allocation, or LDA, are effective for dimensionality reduction. They simplify the matrix while retaining important semantic information. Question 5. Which techniques detect noun phrases, verb phrases, subjects, and objects in NLP? Answer. Dependency parsing and constituency parsing excel here. They parse text to identify grammatical structures, making it easier to extract meaningful relationships and phrases. Question 6. True or false? Cosine similarity values significantly higher than 0.5 indicate dissimilarity. Answer. False. Higher cosine similarity values, closer to 1, indicate greater similarity, not dissimilarity. Question 7. Which techniques are used for keyword normalization in NLP? Answer. Stemming and lemmatization are keyword normalization techniques. Stemming trims words to a simpler form by cutting off endings, while lemmatization reduces words to their dictionary form. Question 8. Identify the NLP use case from these options: object detection, facial recognition, speech biometrics, or text summarization. Answer. Text summarization is the NLP use case here. The others involve computer vision or speech recognition. Question 9. If the term hello appears k times in a document with t terms, and hello appears in 1/3 of all documents, what's the correct formula for TF-IDF? Answer. The correct TF-IDF formula is k divided by t multiplied by log 3. Here, TF, term frequency, equals k divided by t, and IDF, inverse document frequency, equals log 3, as hello appears in 1/3 of documents. Question 10. Which algorithm decreases weights for common words and increases weights for rare words in NLP? Answer. Inverse document frequency, or IDF, decreases the weight for frequently used words and boosts it for rare words, helping highlight uniquely significant terms in a document. That's it for today's video. Hope these explanations make your NLP interview preparation easier. Don't forget to like, subscribe, and hit that notification bell for more insights. See you next time!
Hi everyone, and welcome back to our channel. Continuing from our previous video, today we'll be covering NLP interview questions, complete with clear explanations and helpful examples. Let's get started. Question 11. What is the NLP process called where common words like and, is, the are removed? This process is known as stop word removal. It eliminates frequently used words that often carry less meaningful information, allowing NLP models to focus on more significant words. Question 12. True or false? Converting a sentence into tokens is called stemming. False. The correct term is tokenization, which splits text into individual words or tokens. Stemming, on the other hand, reduces words to their root form by removing suffixes. Question 13. True or false? Tokens must be converted into numbers before feeding them to neural networks. True. NLP models can't process raw text directly, so each token must be transformed into numerical form, often through embedding vectors or one-hot encoding. Question 14. Which among these is not an NLP library? NLTK, scikit-learn, Spicy, or BERT? BERT isn't an NLP library. It's actually a pre-trained language model used for generating word embeddings and understanding contextual language. Question 15. What does TF-ID help to establish? TF-ID helps determine the importance of a word within a document by considering how frequently it appears, TF, and how unique it is across all documents, IDF. Question 16. What is the NLP process called that identifies entities, like people and organizations? This process is named entity recognition, or NER. It extracts entities such as names, locations, dates, and organizations from text data. Which of these is not a pre-processing technique? Stemming, converting to lowercase, removing punctuation, stop word removal, or sentiment analysis? Sentiment analysis is not a pre-processing step. Instead, it's an NLP application performed after pre-processing, used to identify opinions or emotions in text. Which tool converts text into tokens and then into numerical vectors? Count Vectorizer converts text data into numerical vectors by tokenizing and counting the frequency of each token, making it suitable for machine learning models. Question 19. True or false? Words represented as vectors are called neural word embeddings. True. Neural word embeddings, like those from word to V or glove, capture semantic meaning by representing words as vectors in a multidimensional space. Which word embedding supports context modeling considering previous and subsequent sentences? BERT, bidirectional encoder representations from transformers, supports context modeling by taking into account both previous and subsequent sentences, making it highly effective for tasks needing contextual understanding. Thanks for tuning in. Make sure to subscribe and hit the notification bell for more great NLP tips. Catch you in the next video.
Hey everyone, welcome back to our channel. Today we continue our NLP series with some more questions, complete with clear answers and practical examples. Let's jump right in. Question 21. Which word embedding provides a bidirectional context, considering both previous and next sentences? BERT provides a bidirectional context. Unlike word2vec and glove, it analyzes the context from both directions, making it excellent for tasks that require deeper contextual understanding. Question 22. Which word embedding can be specifically trained on a subject matter using transfer learning? BERT can be custom trained through transfer learning, meaning you can fine-tune it on a specific subject or domain to enhance its accuracy and relevance. Question 23. True or false? Word embeddings capture multiple dimensions of data represented as vectors. True. Word embeddings capture semantic meaning in multidimensional vector spaces, helping NLP models understand relationships between words more effectively. Question 24. True or false? Word embedding vectors help establish the distance between two tokens. True. Using metrics like cosine similarity, embeddings allow NLP models to quantify how closely related two words are based on their meanings. Question 25. Which of these is not an example of language bias from historical data used in training word embeddings? Are New Delhi is to India, or man is to computer,
woman is to homemaker. New Delhi is to India is not biased, as it simply denotes a geographical fact. The second example reflects gender stereotypes, thus showing bias. Question 26. Which NLP model is more suitable for tasks like semantic similarity, reading comprehension, and common sense reasoning? Elmo, GPT, or ULM-Fit? OpenAI's GPT is best suited for these complex NLP tasks due to its advanced transformer-based architecture, enabling it to understand intricate patterns and contexts. Question 27. Which NLP architecture first introduced the transformer model? Glove, BERT, GPT, or ULM-Fit? The transformer architecture was first introduced by OpenAI's GPT, revolutionizing NLP by significantly improving the efficiency of training and the quality of language models. Question 28. Which architecture trains faster and requires less training data? LSTM-based or transformer-based? Transformer-based models train faster and need less data than traditional LSTM-based language models, making them highly efficient for NLP tasks. Question 30. Which word embedding technique supports multiple embeddings for the same word based on different contexts? Elmo supports multiple embeddings for the same word, effectively capturing context-dependent meanings that vary depending on how a word is used. Question 30. Which NLP model uses embeddings combining token, segment, and position embeddings? BERT combines token, segment, and position embeddings to create rich contextual representations, enhancing its performance on various NLP tasks. Thanks again for watching. Don't forget to subscribe, hit the notification bell, and stay tuned for more NLP insights. See you in the next video.
Hello, everyone. Welcome back to our NLP series. Today, we'll cover some more NLP interview questions with clear explanations and helpful examples to boost your preparation. Let's get right into it. Question 31. Which NLP model trains two independent LSTM language models, one left to right and the other right to left, and combines their outputs? Answer. Elmo trains two separate LSTM models, left to right and right to left, and merges their outputs to create comprehensive, context-aware embeddings. Question 32. Which model uses a unidirectional approach for producing word embeddings? BERT, GPT, Elmo, or Word2Vec? Answer. GPT employs a unidirectional approach, processing text from left to right, thus capturing context only from preceding words. Question 33. Which NLP architecture models the relationship between all words in a sentence, irrespective of their positions? Answer. BERT utilizes the transformer architecture to model relationships between every word in a sentence, effectively capturing complex contextual interactions. Question 34. List some NLP use cases. Answer. Common NLP use cases include sentiment analysis, language translation, document summarization, question answering systems, chatbots, grammar correction, and intent extraction, among others. Question 35. True or false? Transformer models pay attention to the most important words in a sentence. Answer. True. Transformer models use attention mechanisms to identify and prioritize crucial words, significantly enhancing the quality of language understanding. Question 36. Which NLP model achieves higher accuracy among BERT, XLNet, GPT-2, and Elmo? Answer. XLNet generally achieves higher accuracy and outperforms others across various NLP tasks due to its permutation-based modeling approach. Question 37. Which NLP model features permutation language modeling? Answer. XLNet features permutation-based language modeling, predicting tokens in random order rather than sequentially, providing deeper context understanding. Question 38. True or false? Transformer XL uses relative positional embeddings. Answer. True. Transformer XL employs relative positional embeddings to encode positions based on their distances from each other, improving the model's attention mechanisms. Question 40. What is the naive Bayes algorithm and when is it useful in NLP? Answer. Naive Bayes is a probabilistic classifier based on Bayes' theorem, ideal for text classification tasks like spam filtering and sentiment analysis due to its speed and efficiency, especially when dealing with dynamic and large datasets. Thank you for watching. If you found this useful, please like, subscribe, and hit the notification bell. Stay tuned for more NLP insights. See you in the next one. Welcome back to our NLP series, everyone. Today, we're diving into some more NLP interview questions. Let's go through these clearly and concisely with practical examples. Let's get started. Question 41. What is text summarization in NLP? Answer. Text summarization condenses lengthy documents into concise summaries while retaining the key points and meaning. It can be extraction-based, selecting important sentences, or abstraction-based, rewriting main points in new words. Question 42. What is NLTK and how is it different from SPACY? Answer. NLTK, or Natural Language Toolkit, is a library for symbolic and statistical NLP tasks like tokenization, stemming, and parsing. SPACY, on the other hand, offers optimized and efficient object-oriented tools, supports fewer languages but provides word vectors, and prioritizes speed and ease of use. Question 43. What is information extraction in NLP? Answer. Information extraction automatically identifies structured data from unstructured text sources, capturing entities, attributes, and relationships. Common modules include tagging entities, extracting facts, and sentiment analysis. Question 44. What is the bag of words model? Answer. Bag of words represents text by counting word frequencies, ignoring grammar and word order. This model helps NLP algorithms classify documents based on word occurrences. Question 45. What is pragmatic ambiguity in NLP? Answer. Pragmatic ambiguity occurs when words have multiple meanings, and their correct interpretation relies heavily on context. For example, I can't recommend this person enough could mean high praise or criticism based on context. Question 46. What is a masked language model? Answer. A masked language model predicts hidden words in sentences by understanding context from surrounding words. This technique helps models like BERT learn deeper language representations. Question 47. What are some of the best open-source NLP tools? Answer. Top open-source NLP tools include SPACY, TextBlob, Textacy, NLTK, NLP.js, Stanford NLP, and CogComp NLP. These tools streamline common NLP tasks effectively. Question 48. What is POS tagging in NLP? Answer. POS tagging, or part-of-speech tagging, identifies and labels words as nouns, verbs, adjectives, etc., based on their context within a sentence. It's essential for deeper grammatical understanding and analysis. Question 50. What is named entity recognition, or NER? Answer. Named entity recognition identifies specific entities like names, places, dates, and organizations within text. It's crucial for extracting structured information and enhancing text comprehension. Question 50.
Explain the masked language model in more detail. Answer. A masked language model involves training a language model by hiding words in sentences and predicting them using context clues. This approach significantly improves the model's understanding of language context and semantics. That's all for today. If you enjoyed this video, please like, subscribe, and hit the notification bell for more NLP insights. See you next time.
Hello, everyone. Welcome back to our NLP series. Today, we're exploring next set of NLP interview questions, providing clear and concise answers along with practical examples. Let's jump right in. Question 51. Can you elaborate further on masked language models? Answer. Masked language models improve language understanding by predicting hidden words in sentences using contextual clues. They are fundamental in advanced NLP models like BERT for tasks requiring deep semantic understanding. Question 52. What is pragmatic analysis in NLP? Answer. Pragmatic analysis involves interpreting meaning based on external context or real-world knowledge, helping NLP systems understand implied meanings beyond literal interpretations. Question 53. What is perplexity in NLP? Answer. Perplexity measures how well a language model predicts unseen text. Lower perplexity indicates a better model that accurately anticipates and generates coherent text. Question 54. What are n-grams in NLP? Answer. N-grams are contiguous sequences of n words from text used in NLP for tasks like predicting next words or checking grammar. Examples include bigrams, like New York, and trigrams, like the Golden Compass. Question 55. What's the difference between AI, machine learning, and NLP? Answer. AI encompasses all systems exhibiting human-like intelligence. Machine learning, a subset of AI, enables systems to learn from data. NLP, a specialized area within machine learning, specifically deals with processing and understanding human language. Question 56. Why is self-attention beneficial in NLP models? Answer. Self-attention allows models to efficiently weigh the importance of each word relative to others in a sentence, significantly improving language understanding and computational speed over traditional recurrent models. Question 57. What are stop words in NLP? Answer. Stop words are common, less meaningful words such as the, is, or and. Removing these words improves model efficiency by focusing on words that contribute significant meaning. Question 58. What is latent semantic indexing, LSI? Answer. LSI identifies hidden relationships between words by mathematically analyzing their usage patterns across documents. It enhances information retrieval accuracy by capturing deeper semantic meanings. Question 59. What are regular expressions in NLP? Answer. Regular expressions, or regex, are patterns used for matching and manipulating strings. They're essential in NLP for tasks such as text cleaning, pattern matching, and information extraction. Question 60. Can you explain unigrams, bigrams, trigrams, and n-grams? Answer. Unigrams are single words, bigrams are pairs, and trigrams are triplets. These n-grams capture contextual meaning and are widely used for predictive text modeling and linguistic analysis. That's it for today's NLP Insights. Remember to like, subscribe, and click the notification bell for more useful content. See you in our next video.
Hi, everyone. Welcome back to our NLP interview series. Today, we'll cover next set of questions, providing clear, concise explanations and practical examples. Let's dive right in. Question 61. What are unigrams, bigrams, trigrams, and n-grams in NLP? These are sequences of words. Unigrams refer to single words, bigrams are pairs of consecutive words, trigrams are sequences of 3 words, and n-grams represent sequences of n words. These help capture the context within text data. Question 62. What are typical steps to solve an NLP problem? Typical steps include gathering data,
text preprocessing, like stemming and lemmatizing words, feature engineering, embedding text using methods like word-to-vec, training models, neural networks, or machine learning, evaluating model performance, adjusting the model as needed, and finally, deploying it. Question 63. What are common elements of NLP? Common elements include entity extraction, identifying people, places, etc., syntactic analysis, structuring sentence order and grammar, sentiment analysis, determining emotions or opinions, and text classification, categorizing text based on topics or intent. Question 64. Can you explain NLP terminology with an example? NLP terminology includes vectors and weights, like TF-IDF, text structures, named entities, POS tagging, sentiment features, text classification strategies, like supervised learning, and entity linking methods. For instance, named entity recognition tags New York as a place entity in text. Question 65. What is word-to-vec? Word-to-vec transforms words into vector representations that capture semantic meaning. Words with similar meanings, like apple and orange, appear closer in the vector space, enhancing NLP models' understanding. Question 66. What metrics evaluate NLP models? Common metrics include accuracy, precision, recall, and F1 score. These metrics help assess how well a model performs at tasks like classification or prediction. Question 68. How can we pre-process text input effectively? Text pre-processing steps include case normalization, punctuation removal, stop word removal, stemming or lemmatizing words, and generalizing irrelevant information, which all help reduce noise and improve the clarity of the input for models. Question 69. How does the encoder-decoder structure work in language modeling? The encoder-decoder structure transforms input sequences into fixed-dimensional vectors, encoding, and then generates output sequences, decoding, commonly used in machine translation to convert text from one language to another. Question 70. How would you implement an NLP system as a service, and what challenges might arise? An NLP system as a service involves creating endpoints for inference, feedback loops for model validation, databases to store predictions, retraining mechanisms, and model versioning. Challenges include handling real-time data, scalability, and ensuring accurate performance monitoring. That's all for today. If you found this useful, please like, subscribe, and ring the notification bell. See you in the next video. Welcome back, everyone. Today, we're continuing our next set of NLP interview series questions, providing clear answers and real-world examples. Let's dive right in. Question 71. How can we handle misspellings in NLP text input? Misspellings can be addressed by using word embeddings trained on large data sets that naturally include common misspellings. Additionally, pre-processing techniques like edit distance, phonetic matching, and keyword corrections can effectively resolve these issues. Question 72. Which supervised learning models can classify tweets based solely on the given tweet data? Neither naive Bayes nor SVM can perform classification without labeled target variables. If only tweet data is provided without labeled categories, you cannot train supervised models effectively. Question 73. Which actions affect dimensionality in a document term matrix? Removing stop words, normalizing words, or converting words to lowercase? Removing stop words and normalizing words both reduce dimensionality. Converting words to lowercase might slightly decrease dimensionality by consolidating identical words that differ only in case. Question 74. Which features can improve accuracy in an NLP classification model? Improvement features include frequency counts of terms, sentence vector representations, part-of-speech tags, and dependency grammar structures. Question 75. Are any of these statements true regarding topic modeling? It's supervised, LDA refers to linear discriminant analysis, topic count is independent of dataset size, number of terms is proportional to dataset size. All statements are false. Topic modeling, like latent Dirichlet allocation, LDA, is unsupervised. LDA stands for latent Dirichlet allocation, not linear discriminant analysis. Topic count depends on dataset size, and term numbers aren't directly proportional to dataset size. Question 76. In LDA for text classification, what do the hyperparameters alpha and beta represent? Alpha represents the density of topics within documents, and beta represents the density of terms within topics, influencing the granularity of topic and term distributions. Question 77. What problems can arise with using ReLU activation functions? ReLU can suffer from dying neurons where neurons output 0, effectively stopping learning. Another issue is exploding gradients. Solutions include gradient clipping and using variants like parametric ReLU. Question 80. What's the difference between learning latent features using SVD and embeddings from deep networks? SVD finds latent features through linear combinations, whereas neural network embeddings are generated through complex, nonlinear transformations, capturing deeper semantic relationships. Question 81. What information do hidden and cell states store in LSTM networks? The hidden state stores information relevant up to the current step, while the cell state carries information needed across long sequences, selectively remembering or forgetting data. Question 82. When might self-attention mechanisms not be faster than recurrent layers? Self-attention can be slower if the sequence length exceeds the dimensionality of the representation, though typically self-attention is more efficient for standard NLP tasks. That's it for today's video. If you found it helpful, make sure to like, subscribe, and hit that notification bell. See you next time. Hi, everyone. Welcome back to our NLP series. Today, we'll cover next set of NLP interview questions with clear explanations and practical examples. Let's get started. Question 81. What's the benefit of using a learning rate warm-up in training NLP models? Answer. Learning rate warm-up gradually increases the learning rate at the start of training to avoid instability from early training gradients, ensuring smoother convergence and improved model performance. Question 82. What is the difference between hard and soft parameter sharing in multitask learning? Answer. Hard parameter sharing means multiple tasks share the same model parameters simultaneously. Soft parameter sharing involves training tasks independently, but allowing some information exchange through regularization techniques. Question 83. What's the difference between batch normalization and layer normalization? Answer. Batch normalization computes mean and variance across each batch, stabilizing training and allowing higher learning rates. Layer normalization computes mean and variance for each individual training example, making it effective regardless of batch size. Question 84. Why do transformer models use layer normalization instead of batch normalization? Answer. Transformers use layer normalization because it's more robust to varying batch sizes, crucial for sequential models like transformers where batch size can vary significantly during training. Question 85. If errors exist in your training data, how might you adjust your NLP model? Answer. You can use techniques like label smoothing, which accounts for expected errors, or apply class weights to compensate for known inaccuracies in certain labels. Question 86. What are key techniques used in ULMFIT? Answer. ULMEFIT techniques include language model fine-tuning on task-specific text, weight dropout, discriminative learning rates for different layers, gradual unfreezing of layers, and a slanted triangular learning rate schedule. Question 87. Name a language model that doesn't use dropout, and explain why. Answer. Albert v2 doesn't use dropout because parameter sharing in Albert provides sufficient regularization, making dropout unnecessary. Question 88. What are major differences between GPT and GPT-2? Answer. GPT is unidirectional, processing text sequentially, whereas BERT is bidirectional, simultaneously considering context from both directions, and also includes tasks like next sentence prediction for deeper context understanding. Question 90. How does Albert differ from BERT? Answer. Albert introduces parameter sharing, embedding factorization to reduce model parameters, and removes dropout due to the strong regularization from shared parameters, making it more efficient. Thanks for watching. Please remember to like, subscribe, and hit the notification bell for more NLP insights. See you next time.
Hello, everyone. Welcome back to our NLP series. Today, we're wrapping up with NLP interview questions, offering clear explanations and practical examples. Let's dive right in. Question 91. How does Albert differ specifically from BERT v2? Answer. Albert v2 introduces parameter sharing and embedding factorization, significantly reducing the number of parameters compared to BERT. Additionally, Albert v2 doesn't use dropout, benefiting from parameter sharing's regularization. Question 92. How does parameter sharing in Albert affect training and inference times? Answer. Parameter sharing reduces the model size without affecting training or inference speed. It maintains computational efficiency while significantly decreasing memory requirements. Question 93. How would you reduce the inference time of a trained neural network model MUBUB? Answer. Inference time can be reduced by methods such as deploying the model on optimized hardware, like GPUs or TPUs, using quantization techniques like 16-bit precision, model pruning, knowledge distillation to smaller models, and adaptive softmax strategies. Question 95. Would you use byte pair encoding with classical NLP models, and why? Answer. Yes, BPE helps reduce vocabulary size and improves handling of rare and unseen words, making classical NLP models more efficient and robust. Question 96. Briefly explain how to use TF-ID and semantic encoding for document ranking. Answer. TF-ID initially retrieves relevant documents, and then semantic encoding and cosine similarity refine these rankings by analyzing deeper semantic relationships between query and documents. Question 97. How would you build a sentiment classifier effectively? Answer. Effective sentiment classifiers require clear labeled datasets with neutral categories, fine-tuning using transfer learning on language models, and ensuring a balanced and diverse dataset to accurately capture sentiments. Question 98. What's the difference between regular expressions and regular grammar in NLP? Answer. Regular expressions match patterns in strings, useful for text processing tasks. Regular grammar defines structured rules for generating language constructs, essential for linguistic modeling. Question 100. How is backpropagation different in RNNs compared to traditional neural networks? Answer. In RNNs, backpropagation is through time, incorporating gradients from past states due to sequential data dependencies, unlike traditional networks which compute gradients independently at each training instance. That wraps up our NLP series. Thanks for tuning in. If you found this useful, remember to like, subscribe, and hit the notification bell. See you in the next series.